On the morning of June 30th, 1908, the remote Siberian wilderness near the Tunguska River was shaken by one of the most powerful explosions in recorded history. At precisely 7:17 a.m., local hunters and villagers witnessed a blinding flash of light racing across the sky, brighter than the sun, followed by a massive shockwave that shattered windows hundreds of miles away. Moments later, a thunderous explosion rocked the earth. The force of the blast was so immense that it flattened over 80 million trees across an area of 2,000 square kilometers, roughly the size of a major city. Witnesses described a pillar of fire rising above the horizon, followed by a sound like cannons firing in the distance. For several days afterward, strange glowing clouds lit up the night skies across Europe and Asia, allowing people in London to read newspapers at midnight without artificial light. Yet, despite the sheer scale of the event, no one could determine what had caused it. The region was so remote that it took scientists nearly 20 years to reach the site. What they found was both awe-inspiring and deeply puzzling. Millions of trees lying in a perfect radial pattern, all pointing away from a central point, but no crater. At ground zero, trees stood upright but were stripped bare of branches and bark, as if scorched by a cosmic torch. The soil showed signs of intense heat, and tiny glass-like spheres containing rare elements were scattered across the area. The absence of an impact crater immediately ruled out a conventional meteor strike. Whatever had exploded, it had done so in the air, not on the ground. Scientists began to suspect an airburst event, when a large meteoroid or comet enters Earth's atmosphere and explodes before impact. Based on modern estimates, the Tunguska explosion released energy equivalent to 10 to 15 megatons of TNT, nearly 1,000 times more powerful than the Hiroshima bomb. The shockwave circled the globe twice, registering on barometers thousands of miles away. Herds of reindeer were incinerated instantly, and nomadic Evenki tribesmen living nearby were thrown to the ground by the blast. One eyewitness, Semyon Borisov, later recalled, "The sky split in two, and fire appeared high and wide over the forest. Then I heard a noise like stones falling from the sky, or guns firing. The earth shook and I was thrown off my feet." But even as early investigators pieced together the evidence, the mystery deepened. If it wasn't a meteor impact, what had caused such an unprecedented explosion? Some proposed it was a fragment of a comet made of ice and dust that disintegrated midair. Others believed it could have been a small asteroid that entered the atmosphere at extreme speed. It wasn't until 1927, nearly 2 decades after the explosion, that the first scientific expedition finally reached the Tunguska site. Led by Leonid Kulik, a Russian mineralogist and meteor expert, the team battled through swamps, mosquitoes, and thick Siberian taiga to investigate what locals still described as the place where the sky exploded. When Kulik and his crew arrived, they were stunned. The forest was still flattened in every direction, trees lying like matchsticks, radiating outward from a central point. Yet, in that center, they found something extraordinary. No crater, no fragments, and no trace of any meteorite. The ground itself was oddly elevated, and the soil showed evidence of scorching heat but no penetration. Kulik interviewed local Evenki tribesmen, many of whom still refused to go near the area, calling it the Valley of Death. They spoke of a fiery sphere streaking across the sky and a deafening explosion that made the sky burn. Superstitious fear and a lack of evidence made the mystery even more impenetrable. Over the following decades, the Tunguska mystery fascinated scientists and conspiracy theorists alike. Mainstream researchers leaned toward the airburst hypothesis, the idea that a space object, likely a stony asteroid about 50 to 60 meters wide, entered Earth's atmosphere and detonated at an altitude of roughly 5 to 10 kilometers above the ground. The intense pressure and heat caused it to disintegrate violently, releasing an explosion equivalent to several nuclear bombs. However, without physical debris or an impact crater, skeptics remained unconvinced. In the absence of conclusive proof, alternative theories began to emerge. Some scientific, others wildly speculative. One popular theory suggested the explosion was caused by a comet fragment, composed mostly of ice, which vaporized upon contact with Earth's atmosphere. This could explain the absence of solid fragments and the glowing night skies observed across Europe, caused by water vapor and ice crystals reflecting sunlight. But then came stranger ideas. Some claimed Tunguska was the result of a natural gas explosion from beneath the Earth's surface. a massive release of methane that ignited spontaneously. Others, influenced by the growing fascination with extraterrestrial life, argued that it might have been an alien spacecraft that exploded or crashed in Siberia. Still others connected it to Nikola Tesla, suggesting he had accidentally triggered the event while experimenting with wireless energy transmission from his Wardenclyffe Tower in New York, a claim with no scientific backing but enduring popularity among enthusiasts of fringe science. As science advanced through the 20th century, researchers continued to revisit Tunguska, armed with better technology, satellite imagery, and modern understanding of cosmic phenomena. In the 1960s and 70s, Soviet scientists conducted new expeditions to analyze the soil, vegetation, and microscopic particles embedded in tree resin. Their findings offered the first solid evidence supporting the asteroid airburst theory. Microscopic silicate and nickel-rich particles were discovered in the soil, the chemical fingerprints of extraterrestrial material. Trees near the epicenter also showed mutations and abnormal growth patterns, consistent with exposure to intense radiation and heat. Using modern computer simulations, scientists determined that the object responsible must have entered the atmosphere at about 27,000 kilometers per hour, exploding with a force between 10 to 15 megatons at an altitude of roughly 8 kilometers. This new evidence seemed to confirm what Kulik had long suspected. Tunguska was indeed a cosmic event, not a terrestrial explosion. In 2007, Italian researchers went even further, suggesting that Lake Cecco, a small round body of water located about 8 kilometers from ground zero, might be an impact crater formed by a surviving fragment of the object. However, later studies cast doubt on that theory, suggesting the lake predated the explosion. While the mystery was never fully solved, the consensus among scientists today is clear. The Tunguska event was caused by the mid-air detonation of a small asteroid or comet fragment, the largest impact event in recorded human history. Its effects were staggering. If the Tunguska explosion had occurred just a few hours later, it would have devastated St. Petersburg, then the capital of Russia, killing hundreds of thousands. Instead, fate placed it over one of the most isolated regions on Earth, a cosmic near-miss that may have saved millions of lives. The Tunguska event also changed how scientists viewed the dangers posed by near-Earth objects. It was a wake-up call, proof that the Earth is not immune to catastrophic impacts. In fact, the Tunguska blast is estimated to be a once-in-1,000-year event, yet similar smaller impacts happen more often than most realize. In 2013, the Chelyabinsk meteor in Russia, a 20-meter asteroid that exploded midair, reignited global awareness of just how real the threat remains. The parallels with Tunguska were undeniable. Today, more than a century later, the Tunguska site stands as a haunting reminder of our planet's vulnerability. The flattened forest has regrown, but the mystery still lingers, an eternal echo of the morning when the sky exploded over Siberia, and the world learned just how fragile its place in the cosmos truly is.